Good afternoon, everyone, and welcome once again to this week's ECA Technical Tuesdays webinar. Today we are joined by ECA's very own technical manager, Darren Crannis, who will be speaking to you today about safe isolation and the importance of working safely on electrical systems. Just before I hand over to Darren, a couple of bits from me. You should have a question mark in a bubble on your screen at the moment. Please feel free to click into there at any time during today's presentation, put your questions in there, and we'll get round to as many as we can at the end of Darren's presentation. Today's presentation is accredited. Everyone who's watching us live today, that's just for the live attendees, not if you're watching this on playback. So for our live attendees today, you will all receive an email with a link to your certificate. That's the ECA Professional Development Certificate, 1 hour after the webinar closes. So without further ado, over to you, Darren, for the presentation.
Thank you, Omar, and thank you everyone for joining us today on this Technical Tuesday. Topic for today is safe isolation and the importance of working safely, which we all hope to do, on electrical systems. So the agenda for today, we're going to sort of look at compliance and competence. We're going to go through some sort of safe isolation, so suitable devices and instruments. Also importantly, which some of us forget about, is re-energization. We're going to touch on permits and risk assessments, how the ECA can help, and we're going to summarize that and a little Q&A. As Omar has said, there's a 1 hour accredited CPD for all live attendees, and you'll receive this automatically via email with your CPD certificate about 1 hour after the webinar closes. So let's set the scene. So introduction to myself, I'm a technical manager here at the ECA. My name's Darren Crannis, and I'm an engineer with boots on the ground. So I was an industry leading practitioner and established member of the ECA's technical team, having previously been a managing director of an ECA firm and chair of the ECA Technical Committee. I was an experienced engineer who specialised in electrical inspections, so EICRs, telecommunications, data centres, including generators and critical power supplies. And importantly for today, that included the safe isolation of multiple supplies and sources. Nothing was ever simple. Okay, instrumental into input of Electrical Safety First Best Practice Guide 2, which we'll highlight later on, which is all about safe isolation, and also active in development of various electrical and technical standards, including BS 7671 and a member of JPEL 64. And just to say that the ECA obviously are the largest trade association who help our members, who collectively sort of turn over about £6 billion annually. So that's a lot of electrical work and a lot of electrical circuits that we're working on. So to go through this and put a bit more meat on the bone, incorrect or lack of isolation causes 9+ fatalities a year, which is down from 13 fatalities reported by the HSE or RIDDLE. And these figures come from, that figure comes from 2021. The new figure of 9 reported work-related fatal activities comes from 2021-2022 RIDDLE statistics. So out of those 9, 6 were employees and 3 were self-employed. And there were 155 work-related non-fatal injuries by electricity or electric discharge in 2021-2022. Safe isolation is highlighted in the EAS 2020. Typically in the UK, hopefully, we're all working de-energised, so that's dead. If any live working is required, and this is rare, except when we're perhaps doing some live testing, then guidance such as HSG 85 is very useful. Importantly, we should never assume that a system is de-energised, even when products may be switched off. Okay, safe isolation is absolutely a fundamental safety requirement. So to highlight from these stats, and this is a summary from SuperRod as part of their SuperRod Safe Isolation campaign, and that was held earlier this year in July, August 2024, and they had just under 3,000 responses. Out of those 3,000 responses, 1 in 55 of those responses do not prove dead. 1 in 10 didn't carry a lock-off kit. 25% of that 3,000 rarely or never locks out. And there was a bit of a sway between domestic and commercial. So commercially, 70% of those who responded lock out circuits compared to 30% who lock out in domestic. And it's probably those domestic situations where I'm sure many of you experienced before, where you've isolated a lighting circuit to go and change someone's lights, and you'll turn the lighting circuit off on the consumer unit downstairs, and by the time you're upstairs or in the loft, the homeowner is going to come back and think the lights aren't working and turn that back on. And they're sort of the typical sort of things we see when accidents can occur. So what do we need to consider? So we have legislation and we have guidance, and this all comes down to behaviours, workmanship and processes to achieve conformity with the relevant statutory legislation. So the Health and Safety at Work Act 1974 is the primary piece of legislation covering occupational health and safety in Great Britain, and it sets out the general duties that employers have towards employees and members of the public. Employees have to themselves and to each other. The self-employed have towards themselves and others. It enables other specific legislation to be put in place. For example, Electricity at Work Act 1989. And it's important here that employees and self-employed, so subcontractors, are essentially the same. Okay, they should, when we say employees today, we also mean subcontractors and self-employed. The aim of Electricity at Work regulation is to prevent death or injury to anyone from electrical cause as a result of or in connection with work activities. And the HSE provide guidance on the Electricity at Work Act and working with electricity. There are a number of electrical standards and guides, so Best Practice Guide 2 from Electrical Safety First, HSG 38 about test instruments, and of course BS 7671 about working safely or applying electrical safely. So the law dictates that we should protect our employees, that includes self-employed and subcontractors and others. So Electricity at Work Act Regulations 1989. So Regulation 12 deals with the means of cutting off the supply and for isolation. We need to understand that isolation of electrical equipment prior to carrying out inspections or tests is not just a case of switching off the equipment. We need to understand that isolation involves a procedure that must be followed before inspection or tests on electrical equipment may be carried out. And for equipment which includes a plug arrangement, isolation may be easily established. You can simply just unplug that, but permanently connected electrical equipment, which is probably most of the equipment we deal with, will require more detailed consideration. This extends onto Regulation 13, which deals with the precautions for work on equipment made dead. So in the UK, that is our preferred method. This regulation may apply during any work, be it electrical or non-electrical. So that includes machines. Understand that the regulation uses the term electrical equipment, which includes cables, conductors, wires, connectors, etc., which may have been arranged to connect together the various items of electrical plant or equipment, such as motors, transformers, switchgear. So it may be a collection of equipment. It may be a BMS system, it may be in a boiler room, it might be motors, valves, etc. Understand that a mean of locking off an isolator may be used where such facilities are not available. The removal of fuses or links and then being held safe can provide a secure arrangement if proper control procedures are used. And it talks about also it may be appropriate for safe isolation procedures to be formalised in written instructions, including company policies and procedures. That's often a really good procedure. Permits to work may form part of the written procedures, and their use is considered essential when ensuring systems are safe for work, especially used on high voltage. So anyone who's dealing with high voltage networks will know there's a permit to work for those, and that can be applied to low voltage networks as well. Generally, that's quite a good idea. The Management of Health and Safety at Work Regulations, 1999. So to know that these regulations place an obligation on the employer to actively carry out a risk assessment on the workplace and act accordingly. The assessment must be reviewed when necessary and recorded where there are 5 or more employees. The Management Health and Safety at Work Act is available for free from the HSE. If an employer is prosecuted for a breach of health and safety law and it is proven that they did not follow the relevant provisions of the code, they will need to show that they have complied with the law in some other way, or a court may find them at fault. So the Management of Health and Safety at Work Regulations 1999, isolation does state that isolation can be complex or non-complex. Regardless of what you are isolating, if procedures are not followed, there could be serious consequences. These regulations place an obligation on the employer to actively carry out a risk assessment of the workplace and act accordingly. Risk assessments must be reviewed when necessary and recorded. And it advises that anyone doing the risk assessment should be completed by someone with knowledge of the activity. And HSG 65 also advises the need to train out and instruct people so they are competent to carry out the works. Again, all this information is free for members to download from the HSE website. So that's sort of the legislation around that. Now, the importance of safe isolation, while we must ensure we follow good practice, we need to consider all the risks. So that's the risks to ourselves, our colleagues, the users, and anyone else. These need to be assessed and mitigated. Importantly, all relevant parties should be aware of work being carried out, sort of by building notices, other notices, general assessments, briefings. It's important that correct points are identified. Many times a pre-check or testing of where the isolation points are never identified. So if you're working, for example, on a ring final circuit or other outlets, it's important that you identify every single outlet that you wish to make dead, and also the sources. Appropriate methods of isolation are followed. Equipment used to perform isolation is suitably selected and inspected and sufficient and suitable for the task. So just as an example, we've got a Martindale tester here. So it's ensuring that, the probes are good, the cable leads are good, and it proves right when you put it on a proving unit. And we have to ensure that the isolation that we put on these circuits prevents inadvertently reinstatement of the supply. So someone just can't go there and turn that back on. So, we all know the basics: locking off, checking our equipment, prove the isolation, recheck our test equipment so it hasn't failed. It takes seconds but can save lives. So it's better a dead circuit than it is a dead person. So what have we got out there for industry? Well, Electrical Safety First have a best practice guide called Best Practice Guide 2. Many of us input into this guide. It's free and it's easy to read. You can download it from Electrical Safety First website. It's an ideal place to start creating your own safe isolation policy for your business if you don't have one. Inside that, and we'll come on to that in a moment, there's a safe isolation procedure which you can easily adopt. Typically speaking, really, I guess this should be in everyone's toolbox: a lock-off kit, a proven device, and best practice guide too. Never rely on volt sticks. That's one of the most important things to take away from today. They're not a reliable source. So inside Best Practice Guide 2, there's a safe isolation procedure flow chart. Again, this is all free and available from Electrical Safety First, and gives you some more guidance on that if you want to adopt this or generate your own policy. So looking at this in more detail, yes, we're going to ask for permission from the appropriate person or persons to turn off, to isolate those circuits. And you don't have permission, in which case you're not going to do the works. But providing you've got permission, then you're going to locate and identify the circuit and use an isolation device. You're going to prove your tester works via a proving unit. So test your equipment, make sure it's all good. Okay. You're going to switch off the device and you're going to put an approved lock-off kit on. That there are many lock-off kits. This is an example one for an MCB or a circuit breaker, and you're going to put the appropriate lock-on device on. If you're using things like MCBs, for example, you might use different devices. So there's a variety of devices there and lock-offs you can use, even ones for BS88 fuses for the old MEM and Eaton boards and the old bill boards, or the red spots as people call them. There's a lot of devices you can use to lock off and make safe. We're going to secure that, obviously, with notices. So padlock, key, notice. Notice the padlock only has one key, so no one else can energize the supply. So we're going to secure those to our points of isolation. And then we're going to verify. We're going to verify that those points are dead. And again, we use that using our approved instrument. And importantly, once we verified that the line conductors, the neutral, and going towards the CPC, that is proved dead, we're going to retest our actual proving units to make sure that they haven't failed during that operation. And that circuit's successfully isolated. More on safe isolation is it's not just simple circuits anymore. So we appreciate that this just isn't a simple radio or ring final circuit. There may be more than one point of isolation. Typically, this might be in preferred and non-preferred supplies and changeover switches. And these are common in hospitals, for example, where there might be two circuits to your lighting circuit, data centers, telco, air handling units. So you might even have multiple circuits from essential and non-essential, so generator backed and non-generator backed circuits. We said medical locations and data centers are critical environments, so they have multiple supplies. They're designed never to be isolated, so they might have multiple supplies that you'll need to identify and switch out. You might have auxiliary circuits, so if you're working on plant and equipment and generators, they may have auxiliary heater and charger circuits, which is important that we do remove all sources of energy, just not the primary. We've got a little diagram down here of a solar PV system. So many homes and businesses at the moment are taking advantage of producing their own energy. There's multiple sources of supply there. There is AC, DC, solar, battery backup, UPS. So again, it may be more than one point of isolations. Look out for things like EPO, so emergency power off. You'll see these in laboratories, schools, kitchens. So you may be working on, for example, distribution boards that have 2 or 3 supplies, and one of those circuits may be an EPO system. DC circuits, very common now, and many more. We have other safety considerations as well. So a few of these are flagged up here for you today. Diverted neutral current. So this can occur when there's a break on the protective earth and neutral, the PEN conductors in the distribution network. So what's going on out in the road. And this can lead to dangerous voltages on protected earthing system, including extraneous conductive parts. So you may be forgiven in thinking that TT and TNS systems are unaffected, but you would be wrong. Since much of the distribution network, especially TNS, has become a hybrid network, and that's according to the G12.5. So when that fails, the DNO go out and they just rejoint TNS to make it PME. So you should consider that in the low voltage network, most of that now is TNCS or PME for safety purposes. Guidance note 3, Appendix D, provide detailed description of how to check for diverted neutral currents. So we recommend you read that as well. Another great one, anyone who's worked in a 1960s home will understand the borrowed neutral from the lighting circuit for the hall stairs and landings. So many of us are familiar with sort of swapping out old domestic fuse box with modern boards with RCDs and RCBOs, only to discover that you can't get the lighting circuits to stay on because there's a shared or borrowed neutral. Okay. In this case, of a borrowed neutral, 2 circuits are supplied via a protected device on the load, and the circuit is connected often through the neutral. So you can get some back feed through that. So isolation of just the one circuit can therefore lead to dangerous situation where the circuit may prove dead, but it may be live or become live during work undertaken because of that second circuit and feedback through the neutral. And the final one to look out for things are like capacitors. Okay, so you typically find capacitors in power factor correction or UPS. They should be given suitable time to discharge or have a suitable bleeder designed to safely discharge them so you can prove this dead. You'll find them in most electronic circuits. They're in microwave systems, motors, refrigeration circuit, furnaces, smoothing equipment and power factor systems. So bear in mind that there might be a discharge period on these as well. So let's look at suitable devices and instruments, and it's really important that we use the right kit. Voltage detectors. So understand that contact and non-contact live circuit detectors are recognised in GS38, and that's a free download from the HSE as well. It's important to stress that these are not to be used to prove isolation, only to prove that something's live. So that is things like your contact pens. The item shown on here is a single pole voltage indicator, and that's a contact device. So your sort of isolation pen, well, not your isolation pen, but your voltage stick is what we call non-contact, and we don't really want to use those. We want to use something that makes contact with the poles. So importantly, we use a contact device to prove dead, and that is one of these. So your Martindale sort of type testers, there are others out there. So you have 2-pole, it means you physically have to establish a presence on the contact. So this is using a proprietary test lamp or 2-pole voltage detector suitable. You should use that over a multimeter. So this is my very own, it's a T5 Fluke, and I know many people use this for safe isolation. The trouble is when you use something like a multimeter is they have many different settings on them and you might get it wrong. Okay, so with a proprietary 2-pole tester, there's no buttons, there's no settings, you cannot get this wrong. But using a digital multimeter or an MFT, you can get the settings wrong. So that's why we say that a proprietary test lamp or a 2-pole tester is suitable, not using a multimeter, something like a T5 or T5 from Fluke or your MFT. So it's part of the GS38 requirements to use effectively a 2-pole tester or test lamp. So one of these here. Okay, and they provide guidance on test probes, leads, lamps, voltage detected equipment and measuring equipment. Importantly, these have fused leads where required. The shrouds are protected, so you just push that into your terminals. They have finger guards, a couple on there. They got a visual indication, so we've got some LEDs here which will light up. And importantly, there's no batteries in these to go wrong. So again, it just works if there's voltage present, it will tell you. If not, they remain the lights off. So what's suitable so we talk about suitable. So 2-pole testers, you can buy any sort of 2-pole tester. They're relatively inexpensive now. Proven units. So again, this one's from Martindale, but there are others out there. Lock-off kits, so you can get a load of lock-off kits. That's for a proprietary one for a Schneider. You can get many different lock-off kits, as we said before, and obviously warning notice, one key which you retain with you. And it's important that warning labels should be posted at all isolation points. Safety also applies when we're going to turn things back on too, and a lot of accidents actually happen upon re-energization. So it's ensuring that removal of all locks and ensure that there's no live parts that could cause risk. So equipment's been safely terminated, the covers are all back on, there's no bare ends, there's nothing live, there's no exposed live parts, and also maybe considering a permit to work to say you've gone through these tests. So effectively, sort of backward engineering where you were at the start, you're making sure that everything is safe for that re-energization, and you're correctly going to re-energize the correct circuit. That's okay if you've maybe got one circuit shut off in the whole enterprise, but if you're dealing with, for example, new installations where you might have a selection of circuits energized and others locked off, you want to ensure that you get the correct point of isolation and you unlock the correct circuit, not to injure yourself and others. This leads us nice on to documenting, so permits and risk assessments. Especially we got a lot of circuits that need to be locked off, or enterprises, or you're working in industrial and commercial, it's a good idea to use a permit to work. So it's a technical measure document, and it's required to control work such as maintenance activities to prevent accidents. So it's definitely a requirement for high voltage, can be used on low voltage. It's a great way of introducing a risk assessment and method statement. Importantly, it clearly demarcates an authority, so effectively it hands the circuit over in a safe manner, and it provides me a useful checklist and audit trail. You can design your own permit to work. There's ones available from CITB website, or you may wish to design your own. The ECA on our downloads page and our technical downloads page has isolation certificates available for our members. So we've done some of the work there for you. Risk assessments and method statements. These are often a good idea. A risk assessment should identify any risk and puts control measures in place. And a method statement documents the safe system of work. RAMs, risk assessments and method statements, need to be communicated to all employees. That includes subcontractors. Everybody should be on the same page here. Okay, your own employees, those using the installation, and also your subcontractors. And the ECA has an ERAMS package there to help. So it's essential that we carry these out and carry these out safely. What can we do? We have a lot of technical guides on our website and also on our ECA app. ERAMS is absolutely free to use for all our members, so you could read that there. We have toolbox talks available for safe isolation, and these are available on our health and safety website. ECOMS, our competency tool, is also free, so you can record your operatives, observations and CPDs. So you may wish to sort of observe your operatives carrying out safe isolation procedures, and you can document that, and that will help in your annual assessments by searching the ECA, etc. And our regional managers can help you with this. And of course, you can call, our members can call our technical helpline or email us at technical@eca.co.uk. So mopping all this up, safe isolation is mandatory for requirement for safety. Okay, it's essential actually that we spend a lot of time planning and documenting, and communicating is absolutely essential. We use the right equipment to identify, lock off and prove dead. We ensure that before we re-energize, everything is safe. We've got lots of information to help you on our website, on our app, and we should never risk either your lives or the lives of your colleagues by cutting corners when it comes to safe isolation. And we say there's no excuses or second chances. And we've got a short video to highlight this in a moment. And that concludes the technical information from this Technical Tuesday. So we're now open to any questions you may have. Thank you, Omar.
Thank you for that, Darren. Excellent presentation as always. And don't know if this applies to everyone, but on my side, I had a bit of trouble with the volume on the video. But what I'll do is I'll put a link to that video in the email that you'll all receive in about an hour's time with your certificates. So you'll be able to watch that video again. A few people have asked us if the presentation will be available to members. The answer is yes. So this whole session has been recorded and will be available on our YouTube channel and on the ECA website as well. If you're subscribed to our fortnightly member newsletter, The Source, you'll see it in there as well. So on to the Q&A. We've had a few questions, Darren. So I will start at the top. Here we go. So first question, how should an electrical contractor proceed, or what advice should be provided to the duty holder where RA and employer safety rules are not in place?
So, sorry, can you repeat that one again, Omar?
Yep. I think my connection is a little bit choppy, so what I'll do is I'll also copy and paste that to you, just so you can read it as well. So the question is, how should an electrical contractor proceed, or what advice would you give to the duty holder where RA and employer safety rules are not in place?
If they're not in place, you shouldn't proceed with your isolation. So if there aren't the safety rules in place, then you really shouldn't proceed. You should have that conversation beforehand.
Okay, and this one I think might have been covered off in the video that we just showed. Do you have to use a proving unit, or can you use known life supply?
You can use either. The proven unit tends to be the preferred method. In the absence of a proven unit, then you may resort to a known live supply. So there's the option for both. The proven unit is what we call a sort of de facto, that the first point of call. If you can't, then resort then to a known live supply.
Okay. Next question. We're rattling through these. A few more are coming in. Find my place again. Okay. Is a separate DC isolator necessary at the inverter of a solar PV system if this is incorporated in the inverter equipment?
So for isolation purposes, if the DC isolator built into solar PV inverters, so in the PC equipment, and it meets the requirements for isolation, so importantly, it meets the isolation which is listed in BS 7671, then it may be used for isolation purposes. If not, then a separate one will be required. We talk about sort of this quite often actually. Are they a requirement? Are they not? One, if they are going to be built into the inverter, then you have to ensure that they meet those requirements. If they don't, then you're going to need a separate one. If they are, then you're going to need a method of, if you're testing or if you're replacing that equipment, you're going to need a safe method for doing that as well. And there are means and ways of testing solar arrays without external DC isolators. Typically, you make up your own sort of test equipment for that, and we're happy to have that conversation with our members as well about how they can test sort of DC safely, something we cover separately. But again, yet going back to that, it all depends on ensuring that the inbuilt isolator does meet the requirements of isolation as for BS 7671.
Okay. Next question. Does a proprietary socket outlet polarity or voltage test device commonly used to verify isolation on socket outlet circuits, does that comply with GS38?
No, they're useful for identifying sources of energy. They are not for proving dead. So again, they're to be considered the same as plugging in a lamp, plugging in a socket tester, using a non-contact volt tester. So they identify where they are, but actually proven dead is always done with GS38 approved device, such as this one here.
Okay. Is there a legal requirement to provide a means of local isolation for motors? And what is meant by local? Is it within 3 meters?
That really comes down to risk assessment. BS 7671 and the machine directive also look at rotating machines. So what happens in the event of energy being cut and where that is. Local can be, ambiguous. It can be sort of right next to it. It can be just to the side of it. It generally in the facility of. Generally, it probably won't be in another room, for example, because then you won't be able to isolate that and come in. So it does come down to sort of risk assessment, looking at the requirements of BS 7671 when it comes to isolation of motors. But it's where practical as well, because it may not be exactly within 2 meters or 3 meters, depending on the size of the plant. For example, it may be on adjacent walls, and it may be, as long as it's correctly labeled, then that's what we're really looking for. Some things are built into machines, some things aren't. But again, the machine directive also covers that as well.
Okay. And we've got just a few questions left before I get onto those. Just a note to say that if we do overrun today, and if we're not able to get round to any of your questions today, we are able to review those after the webinar, and we can get back to you individually if we're not able to today. But I think we should be able to cover off everything in the session today. So next question, for commercial applications. Is it a mandatory requirement for an employer to appoint an AP in writing to control and carry out safe isolations and control of switch rooms on site?
They may wish to. If you've got a large electrical environment, then you may wish to appoint it's a competent person. Now, a lot of people have what they call, an authorized person. That's what an AP means. In HV terms, you definitely need what we call an authorized person. In LV terms, someone has to be competent in designing the safe system of work and correctly implementing that. So many people decide that they're going to put an authorizing engineer or an appointed person to do that. Everybody should be able to, sort of when you go through college, you should be able to isolate a circuit. When things get more complex, so you've got a mixture of sources, essential, non-essential, critical, UPS, high voltage, low voltage, then again, that comes down to appointing the correct person to do that. So many larger enterprises will have what they call a clerk of works, an appointed engineer, an approved engineer, someone with a more senior title who's used to doing these safe systems of work. So it's not absolutely critical. What is critical is the right person does it. Often we call that in industry an appointed person, or which is an AP. So not critical, very much useful.
Okay. We've had a couple of questions here from different people alluding to the best practice guide flowchart and the fact that there are very slightly different versions out there. There's the one that we point to on net for the AM2 guide. There's the Electrical Safety First guide. There's our own guidance that we've put out as ECA. The general questions are, what's the best version? What's the best version to use when there's a slightly different order of the steps?
I think the slightly different order of steps actually come down to where you put your probes when you're testing. I think the actual order, the sequence of how you identify, lock, secure, prove your equipment. I think there's a slight difference when it comes down to if you're testing between, for example, live and neutral and earth, where you put your first point of contact. Most of the time people say they prefer to put one probe on the earth terminal first and then go and do the live to live test last. Essentially, that part doesn't really matter too much as long as the procedure is followed. What's really important is that it's identified, it's documented, they're locked off, your test equipment is proven, you prove dead, you test your test equipment after. They are the main important things. The semantics and how you go about that might be slightly different. For example, we talked about UPS systems and battery systems, where you may actually also be looking at discharge. So you may be clamping around the conductors and waiting for current and voltages to fall to reasonable levels before you start pulling fuses, for example. So, but best practice guide 2 is an industry consensus. So that's not only the ECA, that's also other trade associations and CPS providers sort of in the UK. So it's us and others who agree to that. And certainly it's something we think that everyone should have in their toolbox. But I appreciate there are very slight different tweaks to this. Again, it's just having a safe system of work.
Okay. Next question, is physically disconnecting a cable from the overcurrent protector device an acceptable form of safe isolation?
Disconnection is also a form. Just got to ask yourself, is a safe system of work in place while you disconnect that conductor? So many people do disconnect the conductors. However, just realize that you might actually have to remove a cover off some piece of equipment or distribution board or consumer unit whilst you then access that unit live to remove a conductor from a terminal. So again, that will come down to a risk assessment and method statement of how you're going to access that conductor in the very first place.
Okay, and I believe we have one more question here. Is it mandatory for employers to provide all electrically competent employees with the appropriate safe isolation equipment, test lamps, proving unit, lock-off kit, etc.?
If their role, so if that employee or subcontractor, for example, we call them all employees, if they need to de-energize a circuit, they should have the tools provided for them. Now that may be done by an AP. So some organizations may have their level 3 approved electricians, and they should be perfectly capable of isolating circuits. And if that is the case, if it's their job to do the isolation, they should have all the means and tools necessary to do that, and they should be competent at doing that as well. If you have in your organization someone's task to do that job, so no electrical contractor in that organization is allowed to isolate a circuit, then your AP will do that. So some organizations where I've worked, the clerk of works or the AP will do that isolation or has done that isolation for me. They will be into that control. They will sign the permit and they will give that permit, for example, to the electrical contractor to say that that circuit is now safe. Electrical contractor does the work, so they don't need any tools to isolate or re-energize because it's been done for them on their behalf by an approved person. And at the end of their works, they will put their test results down, for example, or notify what they've done. They will show the clerk or the AP the works that have been done. They will verify that with the AP. They will close up anything that's exposed, and then the AP will then go and energize that circuit once it's been handed back. So it's not essential for everyone to have it, but certainly anyone who makes an isolation will need the appropriate equipment, and that's what the HSE and that's what the relevant sort of health and safety laws say.
Okay, we will wrap up there. Thanks once again to all of our attendees. Like we've said earlier on, you'll receive a link to your professional development certificate in about an hour's time. I've also added in there a link to the video that Darren shared earlier with sound, and a few links to some of the ECA resources that we've mentioned here today as well for you to refer back to. And like I said, this presentation has been recorded and will be up on YouTube shortly. So that's it for today. Thank you very much, Darren. And thanks everyone for joining us, and see you next time. Our next Technical Tuesday will be, if my page will just load here so I don't get it wrong. So we've got a couple of webinars coming up. If I can just keep you all for a couple of minutes. The ECA Learning Zone with our commercial associate, Ammo Cable, That will be next Wednesday, November the 6th, with Ammo Cable and Gary Parker, our Head of Technical Standards, going over cabling and common issues with cabling there. And then our next Technical Tuesday will be with our colleague, our Technical Manager, Curtis Jones, on verification of earth fault loop impedance. Super topical, once again. That will be on Tuesday, November the 19th at 12 p.m, same time as usual. Okay, we'll log off there. Thanks, Darren. Thanks,
Thank you
everyone.
very
Have a
much.
great rest. Thanks.